Okay, hey, we're going to condense the following and just kind of look at here. We're going to use our properties of logs, all right, which we have right here. And looking at this here, I see a 3 in front, which makes me think I'm going to be using this log 3, and I do it right here. So I can move that 3 onto the 4. And now I have both logs of the same base. So basically, that's this property right here. If they're adding it, you can just multiply them. So I basically have 4 cubed times 6. Well, 4 cubed is 64 times 6. So I have basically log 3 of 84. That would be condensing it down about as much as what I can do other than actually putting that in the calculator then and getting the answer. All right. So same thing here. I'm going to move the 2 on the 8. They're both log 3s to the minus, but instead of a minus, that means it's a divide. So I'd have 8 squared over 16, which is 64 over 16, which is a 4. All right. That's just condensing them down to something simple. I'm going to do the same thing here. Now, here I'm kind of do a little bit first here. You could, first off, log 2 of 2 is 1, and 8 is the same as 2 cubed, which then if I have 2 cubed, move that. That's the same thing as the 3 in front of the log 2, which is 2. I can move this 2 over here on the 3 squared. That cancels out, meaning I'd have 3 times 1 or minus 3. This would be 2 times 3 squared, so you'd have basically log 2, 9 minus 2. Now, that's what I was thinking it wanted, but that wasn't the answer it wanted here. What it really wanted you to do was this. Just take the 2 and 5 and move them on top of the numbers like that. They're all logs 2, so I'm going to take the 3 squared times the 2 to the 5th divided by the 8 because a plus is a multiply, the minus is a divide. And now as I do that, I'm going to end up with then it's 2 cubed. I just got to cancel out 2 squared. Basically, I have 2 more 2's up here, so that's 2 squared, which means I have 9 times 4 or log 2 of base 36. I think that's the answer they actually have in the book that they will find out. But to me, this is also correct over here. You get the same answer either way. All right, so now then, here, how do I work this one? Well, basically what I would do is this. I'm going to rewrite this. That plus means that you could rewrite it as a times. And if I times that, it would be written up like this right here. And how do you get rid of a 3? Well, that's the property of logs. And I'm going to do this here to get rid of this log. I put some of that up in the exponent, and that makes the answer to the x. So I'm going to take 3 basically to this here. This will cancel out. And I'll make a 3 squared over here. Putting them in the exponent form, basically. So then I'm going to minus 9. Right, now here's where we get into the hairy stuff. That won't factor. So I have to go to my quadratic formula. All right. Oops, I can't find a good spot for the picture. It doesn't look like. A is 1, B is negative 12, C is 18. So plug it in. So the opposite of negative 12 would be positive 12. Negative 12 squared is 144. Negative 4 times 1 is negative 4 times 18 makes negative 72. I minus those, so I'm going to get that right there. All right. Square root of 72 is decimals, about 8.49, which I'm going to add and subtract 8.49 to 12 and minus 8.49 from 12. That's why I see these two different numbers here divided by 2, which gives me that. Now, however, there's not 2 answers to this one because if I go up here and I put 1.755 into that problem up here top, notice, and my straight get negative 1.245. You can't do a log of a negative number. It's not a number you can take to the 3rd power to make it a negative answer. So therefore, that answer is not possible. Meaning the only answer is this 10.245. Woo! What a difficult problem.